Hello, everyone. Welcome to our final thesis presentation. I am Mariam Al-Ghubairi, and this is Nadine, Noor, and Yusuf. So let's take a trip back to the 1980s, where Boris Becker, the renowned tennis player, was known to have a serve so powerful his opponents could barely react to it. Then, one day, as Andre Agassi was preparing to play him, he noticed through some footage that Becker actually sticks his tongue out in the direction that he would serve. And just like that, he managed to turn his opponent's biggest strength into a predictable weakness. This moment did not just shock the sports world, it also revealed the hidden power of movement and pattern analysis through footage. And today, over 40 years later, with the technology that we have and with AI dominating various industries, we can now extract useful insights faster and more accurately than ever before. So right now, we have sports analytics prevailing in various sports such as football, basketball, and many others. And currently, the sports analytics market holds a value of $5.5 billion and is expected to grow by up to 5 times over the next decade. So as many sports are racing towards data-driven analysis, some have unfortunately been left behind, and one of which is squash, where Egypt stands unmatched. As we currently speak, 6 out of the top 10 male players worldwide are Egyptian, 4 out of the top 5 female players are Egyptian, and this is not a one-season wonder. We are global champions year after year, and hopefully in 2028, we will be Olympic champions too. And this is where our thesis begins. So what is SquashSight? It's an AI-driven tool that provides squash players and coaches with tactical analysis in order to enhance player performance and improve coaching efficiency. So we'll walk you through our system design, starting with the input. So what does our application take in? It takes a video recorded at a rate of 30 frames per second or higher, and we simply require it to be taken from the typical audience angle, which is an elevated front view of the court. All you have to do is upload the video, and SquashSight does the rest. So now for our first technical module. What's the first step? It's to digitize our court, and that's what the court calibrator does. So what is the challenge? Well, the coordinates on the frame don't actually match real court positions. And so if we come to track or detect anything, if we use the pure pixel values, then all of our detections become skewed. And so how do we fix this? Well, we used an instance segmentation model, which basically detects the key points on the court, and so it detects the box, the T boxes. The T zone is the red intersection that we see in the middle here. It also detects the tin, which is the lower metal part of the wall, and the lower half of the wall below the service line. So once we detect those key points, what do? We apply something known as the homography transformation, which simply converts the pixel coordinates into real measurements in terms of meters. Were we successful? We definitely were, and we managed to achieve an accuracy of 99%, and now we have our digitized squash court.
Okay, so now we know how we're going to move from pixels to real life. We have our transformation ready. So what are you actually doing when you're watching a squash match? You're looking at the ball, you're looking at the players. So we're going to start with our players. It's really, really important for any analysis that we're going to do that if we detect the players within a frame, whoever we choose to be player 1 in the beginning is the same person that we choose to be player 1 in the very end. And this is the biggest problem that we started with when we came to do our implementation. So the way that we solved this problem is through a hybrid model. First, we chose a model called YOLO V8 Medium, and it's medium so that the detections were provided in a timely manner. This model detects the players, and it detects multiple aspects of the players: their wrist, their ankle, their feet position, their hips, and all of this feeds into later analysis that we use to come up with good tactical solutions. Our second module is the ResNet 50 model, and what it does is it extracts the visual features of our players. We know that they're going to be wearing, for example, different colored shirts, and this model is what's extracting that information for us so that we can then use it to decide which player is player 1 and which player is player 2, no matter how many times that they're running across each other or going to different sides of the court. And this Sorry. And this approach led us to an accuracy of 94.3% for both players throughout the whole video.
Okay, so now that we've detected the players, we also need to detect the balls. So what's the fundamental problem of ball tracking? Well, first of all, the ball is very fast, it's very small, and it can be occluded. So our solution is to use a model named TrackNet, which is a deep learning network for tracking the tennis balls. And it takes in a sequence of frames, specifically 3 frames, and it outputs the position of the ball on the frame. However, if some of you may know that some squash matches have black squash balls and others have white squash balls. So to mitigate this issue and normalize the input, we simply invert the frames where the matches have black balls. And this gave us an overall accuracy of 98.5%. So now that we have the outputs of both the ball tracking and the player tracking, we feed them into the rally segmentation module. Our goal is to detect when the rally starts and ends in order to extract the useful frames for analysis. In order to do that, we simply take the ball positions, both players' positions, and feed them into the LSTM model, which is a history-aware model that takes sequential data in order to capture the temporal context. As you can see from the evaluation, we managed to reach 100% accuracy in detecting the rally segments. The 85.3% in boundary accuracy is evaluating the exact frame level where the frame starts and ends. But for our use case and our system, we actually can tolerate a little bit of accuracy. So now that we extracted the useful rally segments, we feed them into a hit detection model. What we detect are when the ball hits the wall and the rackets. To detect when the ball hits the wall, we simply invert the y coordinate of the balls, and we find the peaks, and then we use the wall homography matrix to get the real hits on the wall in meters. After getting the wall hits, to get the racket hits, which is when the player hit the ball with his racket, we simply find the closest point with the steepest slope before the wall hit happened. And we approximate the racket hit position with the player position that hit the ball. So you now may be wondering, why do we even need to detect the racket hits or the wall hits? Well, actually, with the culmination of all of these results, we can actually get the stroke detections, the shot type classifications, and the rally outcome. First of all, for the shot type classification, it actually boils down to 2 things: shot depth and shot direction. By shot depth, we mean how far does the ball rebound off of the wall, off of the front wall. If it rebounds long, that means it's a drive. If it rebounds short, that means it's a drop. For the shot direction, it's a cross court. If the player who hit the ball rebounded off the other side of the court. If it rebounded off the same side, it's a straight shot. And using these 2 properties, we can then combine them and come up with our shot type classification.
Now for our next module, we have the stroke detection module, where our goal from it is that we need to detect whether the player is playing a forehand or a backhand. This is particularly useful for an analysis, and in order to do this, there is a lot of pre-processing done. So we use the outputs of the previous modules, more specifically the racket hit module and the player's tracking module. But for the player tracking, it's very important to normalize the player key points to be relative to the player's hips rather than pixels. We would like to avoid anything pixel-based because every video has different frames and different videos. And then we input this into an LSTM model to capture the sequential motion of the player. And then after this, we were able to achieve a 98% accuracy with this model.
Okay, and for our final analysis or detection module, we need to obviously know who's won the rallies, and we need to know from that who's won the matches, who's won the game. So we're not going to be giving you guys a whole presentation about squash without giving you a few fun facts. So I'm going to tell you how to win a squash rally. It's easy. You just have to hit the ball in the right place. You're either hitting it on the wall or on the sides. You can't hit it on the tin or above a specific line that's already drawn on the wall. Obviously, sometimes there's things that happen in a rally where it means that you have to go and replay the rally, and this is what we call a let. And a few more rules of squash: if you do win the rally, you get to serve. And if you win again 2 times or 3 times in a row, Mabruk, well done, but that means that you have to change the position that you are going to serve on. So we use all of these rules to create an algorithm to decide who has won the rally or not through the video. So it's very simple. We check. If it's the last rally, we're going to see the position and the player of the person who served, and we're going to check. If it's the same as the last rally that we checked, then we can definitely say that this was a let. If it's not, then we can decide who's won the rally. Otherwise, if it's the last rally, we obviously don't have another one after it to go and check who's serving. So what we do instead is we check the ball position. If it's within bounds, so it's not on the tin or it's not above the line that we mentioned before, then we can definitely say that the player who served is the player who won. And all of this is fed through all of the modules we just talked about. The wall hit detection, the player positioning, all of it. And so we're going to use all of this data that we've now collected to create our game analysis module.
Okay. Our game analysis module is the most important module in our tool. Why? Because it actually provides us with the insights and the analysis that the coach and the player would actually use. So we sat with former squash coach Karim Darwish in order to actually listen to his comments and his input in order to know what analysis we should include, how we should include it, and take his feedback in general. After doing this, we bucketed our analysis and data into 3 main tabs, which are the performance and shots, the movement and positioning, and the rally analysis. So the way our project works is that we take the data from all previous modules combined in like CSVs, and then we store them in database. And then after that, we use an API calls in order to call the queries to compute the analysis that we want to display. And then after we've fetched the queries, we display it to the user as graphs or as natural languages using LLM. Now we can actually see how our tool works in practice using this demo. So first of all, the user is prompted to enter a video of their choice, and the pipeline runs in the background. Then the user will select the player names using this tool in order to determine who's player 1 and who's player 2. And then we go to the homepage, which shows us an overview of our application. And it just displays general information regarding the points won, the players, the winning streaks, the players in general, just basic statistics. And then moving on, we have a more in-depth tab, which is the performance and shots tab. So in squash, players usually like to follow very specific tactics to confuse their opponents. For example, they would like to hit the ball far away from them to make them, to exhaust them. They would like to vary their shot types in order to be unpredictable. And they would also ideally like to, they would also like to just have fast shots in order to limit their thinking time. And this can be seen through these graphs that we are, This can be seen through these tabs that we are displaying over here and the winning efficiency of the players. Moving on to our next big tab, which is the movement and positioning tab. This is mainly focused on the distance covered by each player and the T-zone dominance. Why is the T-zone dominance very important to us? Because the T-zone in squash is very significant to all players, and they would always strive to be in the T-zone. Why is this? Because to them, this makes it accessible to shoot any shot coming at their way while limiting their exhaustion. And this is displayed through heat maps and the graphs shown over here. And again, for our last tab, showing graphical data. For our last tab showing graphical data, we display rally analysis in general. For example, we have a very strong analytic over here, which is the shot intensity of the match. This counts the frequency of the shots, or basically how many shots were done per second. This shows the intensity and aggression of the rally itself. And then we have the final tab, which is the AI assistant tab. This tab, the user can prompt the AI agent any prompt they would like to know, and any specific analytic that's not any specific analytic, and they would get a natural language, and it's actually very interactive. It would ask follow-up questions and actually give actionable insights, not just static graphs. And this makes it more user-friendly because you don't really need a statistical background, and you can follow up with the AI agent itself. And now for the testing. How did we test that our module is actually functional and usable? Well, Through every step of creating the modules, we've tested the accuracy thoroughly with videos that actually challenge the model, not any easy model, not any easy video that would give us high scores. And once we were satisfied with the scores that we've gotten, we've integrated everything together and run the whole pipeline in order to make sure that it's actually working the way we want it to work. And then after finishing all of the technical work, we've taken it to the users. We've tested it on multiple users, players, coaches, etc., in order to check the usability and how interactive the application actually is and how easy it is to use and follow up.
Okay, but also we've been working on this project for a year. All of these modules, all of these implementations, we're the ones that developed them. So we're definitely going to be a little bit biased. So right now, I'm telling you, you don't have to take our word for it. Instead, you can take the word of the former #1 champion.
Hello, it's Ali Farag here. As a former squash player and a huge squash fan for the rest of my life, I'm very excited for what Mariam, Youssef, Noor, and Nadine are building. I think it's an app that's well needed in the squash market. And from what the prototype I've seen already, it looks very promising, very exciting. And I wish them nothing but the best. And inshallah, I'll be recommending it whenever it's ready for all the squash players around the world.
I mean, we didn't even pay him to do that, I swear to God. But now I want you guys to become our investors, think in business. You guys are now our sharks, and we are trying to sell our product to you. So we can actually operate as both B2B and B2C. We could be selling this product to associations, clubs, big squash clubs that would put this product into all of their courts. And then for B2C, we could sell this to enthusiasts, people who like to play squash for entertainment, for activity, or if they're trying to increase their skill in this sport. And why would they even choose us? Well, actually, we found that squash is the gap in the sports analytics market. We are the first people to develop an application like this that is based specifically for squash. We've also applied a lot of techniques to make sure that the analysis is provided in a timely manner. We've applied quantization, batch processing, parallel processing, and all of this got us to a 2x speed up. We also don't need any sort of special equipment. All we need is any device that can take a video, whether it be a camera or your phone. Just put it in the top front view, put the video into our application, and the analysis will be provided to you. And also, we definitely believe that this is a profitable product because there is going to be definitely a high demand on it.
Okay, so we've acknowledged that it's profitable, but how would we materialize this potential into cash? Well, obviously, we'd be charging varying subscriptions depending on our user type. And so for academies and associations, we'd obviously be charging like bulk packages as opposed to individual users. We also plan on doing some advertising. We can start with something slightly cuter, possibly on social media, and then we can scale upwards from there. And in terms of sponsorships, well, I think you all just saw that we've managed to build a few pretty impressive connections in the industry already, and so we can use those in order to sponsor our work. And so what are our empowerment outcomes? We end this project with our amazing demo app and our research paper. And that is all. Thank you so much.